everyone, my name is Atul Negi. I'm here for Gate Booster session on engineering mechanics. I hope everyone is doing great in the gate preparation. So to help you out in your gate preparation, we are here with the Gate Booster session. So the purpose of Gate Booster session is to just boost your gate preparation part. And in this gate preparation part, what is important here? To solve quality problems. Okay. So to gain the confidence, always remember this thing, you will gain the confidence when you will solve quality problems. So in this particular session, what you can expect from here, we will be solving all the quality problems from all the chapters, and these questions will be most expected for your upcoming gate examination. We will not only solve the questions, we will be discussing the concepts as well. Okay, so please take out your copy and pen, and in this session we are solving a beautiful questions for you. Okay, so we'll start the session here everyone, and remember this session is for both mechanical and civil engineering students. Okay, now a very important information to everyone, you can join our Telegram group to get the PDF of this particular session, and as well as you will be getting the important notification for your job, as well as all the informations regarding webinars that we are conducting. Okay, and one more thing, you will be having the daily quizzes that will help you in your gate preparation examination. So you can join the Telegram group, there is a link provided here and also in the description box. Right, now a few more information regarding the live program that we are conducting. Okay, in the live program we have more than 800 hours of sessions, and which you will be getting, apart from 800 live class sessions, 30 plus years of previous year question book you will be getting. Apart from that, exercise book you will be getting, theory books you will be getting, and most important feature of this live program is you will be getting one-to-one mentorship sessions where you can directly connect with the faculty and you can discuss your doubts and as well as whatever queries or the challenges you are facing in your gate preparation journey. So faculty will be meeting with you. Okay, personally you can discuss all your doubts. Hi Saurabh. Okay everyone. So, and if you want any free counseling sessions, you can directly book your counseling session just by clicking on the description box. There is a number provided, you can directly call on. Okay, you can directly call on that number. Now, so in today's session, what will be the order of the topics here, everyone? First topic will be equilibrium, truss, then we'll be discussing friction, and after that centroid, moment of inertia, and finally vibration. Please remember, vibration is specifically for the civil engineering students. Okay, that already in mechanical we are discussing in theory of machine. Okay, so what I will going to do here, first I will discuss some small concept so that at least you will have an idea. Okay, from this concept we will be solving one beautiful problem. Okay, so everyone please take out your copy and pen and start solving question with us. Okay, and in a meanwhile you can share this session to your friends as well so that they can also join and they can also participate in this live question sessions. Okay, and one thing I can guarantee you, if you attend this session you will be gaining the confidence, because the point here is you will gain the confidence only when you will solve a quality problems, and the quality problems you can expect from these sessions. Not only in this subject, all the subjects we are having this gate booster sessions. These sessions are specifically designed to just enhance your preparation part, and it will help you to maximize your gate score. Okay everyone. A very good evening Rahul, a very good evening. Okay, now we'll start with the equilibrium, guys. Okay, so first topic, equilibrium. Now the concept that you need to understand here in the equilibrium, we have two types of body. When we are discussing engineering mechanics, there are two types of bodies, particle and a rigid body. So there are separate equilibrium conditions for particle and rigid body. So that first of all we need to understand. Okay, so if I talk about the particle, what are the equilibrium equations that we are having? Summation of forces along horizontal direction 0, summation of forces along vertical direction 0. These are the two equilibrium conditions for particle. And if I talk about the rigid body, okay, if I talk about the rigid body, we have three equations of equilibrium. First two are same, like summation of forces, horizontal direction 0. Second, summation of the forces in vertical direction 0, and finally summation of moment 0. So these are the three equations of equilibrium. Now try to understand this point. When we are writing summation of moment, okay, summation of moment 0, it means at any point the moment value has to be 0, the net moment value has to be 0. Okay, because if it is not 0, then there will be some moment effect because of which rotation might happen. So to ensure the complete equilibrium, the moment value has to be 0 on all the points. Okay, sometimes students are confused, like, sir, where we have to take the moment? Okay, you can take any point. If the body is in equilibrium, you can consider moment at any point on the body, because at all the point it has to be 0. Okay, even if at any one point the moment value is not 0, then definitely there will be some momentary effects will be there, rotation might happen, and because of which equilibrium cannot be maintained. Very important point. Okay, very good evening. Okay, so particle, rigid body. Now apart from particle and rigid body, there are two other names. If I talk about particle, you can also call it by the concurrent force system. Okay, if any body is having concurrent force system, okay, so there will not be any moment. If the force system is totally concurrent, which means the point of application is same for all the forces, point of application is same, it means concurrent force system. So for that concurrent force system, body becomes a particle only. In rigid body, we usually call it non-concurrent force system, and because of this non-concurrent force system, there will be the moment values. Okay, in concurrent force system we can't have a moment, just because of a reason all the forces have a same point of application. Clear? I hope this point. So these are the basic equations that you need to understand. In all the problems of equilibrium, this is the concept that we need to use in all the problems. Now what problem usually student will face? Just because of some geometry parameter or some because of some mathematics calculation, they are not able to solve the question. And apart from it, there is one more thing, free body diagram. In engineering mechanics, right, if you want to solve any problem, the free body diagram is the step number first. That is the step number first. Okay, if you are drawing the free body diagram correctly and then using the correct equations of equilibrium, you will get the answer very easily. After that, only mathematics is involved. First free body diagram, using correct equations of equilibrium, then after that mathematics and the calculation part. But most of the time we will be doing mistake in the free body diagram itself. And if you just see the previous year questions also, there are a lot of questions they have asked from the free body diagram. Directly question come from the free body diagram. So you should know what is free body diagram, right? So if may I ask this question to everyone, like, what is free body diagram? There is a word free body diagram. Okay, try to understand the term here. Free means all the contacts if you remove. Let's suppose there is a body and it is having contact with any other bodies. So just you need to remove all the contacts. After removing all the contacts, you need to apply all the forces. Forces can be the self weight of the body. There can be some external force as well. And there can be the forces because of the contacting surfaces, like normal reaction, friction force. These are the forces that will be acting on the body. Okay, clear everyone? Very, very important, right? So these are the three equations for the rigid body, equation 1, 2, 3, and this is equation 1, 2 for the particle system. Okay, clear? I hope this point is clear. So summation of forces, horizontal. See, I have written x and y, but it is not necessary always horizontal and vertical will be there. Any two mutually perpendicular directions we can take. Okay, just for reference I have written x and y. It doesn't mean that always horizontal, always vertical. Two mutually perpendicular directions we have to consider. Clear? Okay. Now, the question that we need to discuss here, first of all, this one. Okay. So this is the question, guys. Everyone will start solving this question and tell me your answers. Options are in front of you. Okay. Start solving this question. You have 2 minutes for this question. Okay, I will give you the time also here. Okay, start solving everyone. Very basic question. Just read the question very carefully here. What they have mentioned here. Okay. Very important information they have mentioned. Maximum weight we have to find out. Okay. That can be suspended. Okay. In the position shown. Now, what they have given apart from that, if chords AB and CAD. First chord is AB and CAD. This is another chord. Can each support a maximum tension of 80 Newton. This is a very important information. So we have to utilize this information, the maximum tension a cord can support. This information we will utilize here to solve this question. Everyone try this particular problem. Yes. Equations of equilibrium you need to apply, but before that free body diagram is what we need to draw. Okay. Do it everyone fast. Thirty seconds left, guys. Do it fast. Maximum tension is 80 Newton. And one more thing, this is the cord which is going over the pulley. On both the side, it should be having what? You are getting B as an answer. Okay, we'll see what is the actual answer. Time's up, guys. Okay, anyone else? Okay, anyone? We got one answer as B. Okay, we'll see what is the answer here, but I'm waiting for other people to answer also. Okay. Now see, very important point here. First of all, the free body diagram here. Okay, first of all, the free body diagram. I will draw the free body diagram here itself. I will draw. So this is the pulley here. Okay, this is the cord we are having. There is one tension here like this and another like this. Now one thing you should understand, if we are pulling here with F value, obviously here also the value will be what? Same value will be having. Now this cord is supporting what? The W. It is supporting W here. So this F value and W value has to be what? Equal. First of all, this information everyone clear? Now this is the tension in AB, and maximum value of the tension is already given in the question. That is a very good evening, Rocky. Okay, maximum tension is already given. So maximum value of tension is 80 Newton. Now if I have to apply the equilibrium equation, first equilibrium equation will be summation of forces along horizontal direction 0. Okay, very important point. Right, now see, then another equation that we can apply here is summation of forces vertical 0. Now if I apply the first equation, this is the 20 degree they have mentioned. So from the vertical it is having 20 degree. Okay, this is the total angle theta already they have mentioned. Right, okay. So if I have to write, what I will be writing here, F, okay, F sin theta, and here this is inclined, so there will be one component in the horizontal direction. So it will be, let's suppose towards left I will take negative here. Towards left I will be taking negative, so it will be T sin 20 degree equals to 0. So this is the first thing. Okay, this is the first relation we got. Now similarly, if I use the second equation, summation of forces in vertical direction, T cos 20 degree, T cos 20 degree. After that, what will be having? W in the downward direction. Okay, minus W minus, okay, Instead of using F or W, we can use W here because we need to find out W here. So better we will be using W instead of using F. So it will be W cos theta equals to 0. Clear? I hope this is clear, everyone. Now instead of using F, we will be using W because W is the main unknown that we need to calculate here. So better to write W only. These are the two equations. This is equation number 1. This is equation number 2. Using equation 1 and 2, we need to solve. Now after writing these equations, only mathematics is involved. That's why I'm telling you mathematics plays a very important role here. Even if you have written this equation and you are not able to solve this one, after that, then what you will do with the concepts? That's why practicing quotient will help you, okay, to understand what are the concepts we need to know apart from the basic, our technical concepts. Mathematics concept is also required here, okay. So here trigonometry equation plays a very important role. Clear, everyone? Is this part clear? Got it? Anyone got the answer apart from, okay? Yes, B is the correct answer here. B is the correct answer. Your answer B is 42.56 is totally correct, okay. Option B is the correct answer. So what you will do here, simply write W from here, T sine 20 degree divided by sine theta, and from here you will be having T, okay, we'll write it in the next page, no issue. Okay, from equation 2, from equation 2, what we can write? Tension T cos 20, T cos 20 minus W cos theta equals to 0. Now from here what we can write for T value? W, if I take common, it will be 1 plus cos theta, clear, divided by cos 20. So let's suppose this is the equation number 3, okay. From equation number 1 we got the W value, okay. From equation 1 we got the W value, and from equation 2 we got the value of this tension T. Actually we want to find out the what? W. Yes, absolutely, Rahul. B, Abhinav, answer B. Yes, absolutely correct. All of you. Great. Answer is what? B. Okay. But just need to understand tension here. We need to eliminate the tension because we want what? Which answer we want here? W. Better I will equate what? The tension values. Okay. So from equation 1, what I can write here? This tension equals to W sin theta, okay, W sin theta divided by sin 20. So this is equation 4. So from 3 and 4, from equation 3 and 4, you can easily get the answer of W. But before that, what is the angle of theta? Anyone please tell me what is the answer of theta here? Okay. What will be the answer of theta? Because before calculating W, we need to know the theta as well. Tell me what theta you will be getting. W answer is correct, but what is the theta value? Abhinav, Rahul, anyone? B answer you got correct for the W weight. But what I am asking, what will be the answer of this theta? What is the answer of theta? Anyone? Okay, just equate this equation 3 and 4. You will be getting the answer of theta as well because W will get cancelled out. Theta value you will be getting. Just try this one also. Okay, you have calculated option B, that is correct. 110 degree, no, 110 is not correct. Theta equals to 110 degree, no, theta 110 is not correct here. Okay, simply equate this one. Everyone try. 110 is not correct. Just again cross check your answers. Theta value will not be 110 degree. See, that's why I'm telling you calculation plays a very important role here. Okay, even if we understood the concept, but still we are doing some mistakes because of some mathematics, that's not good here. Okay, because all of your hard work will go waste if you are doing mistakes in the calculation parts. Clear? Right, everyone? So just if I equate both the equations, equation 3 and 4, so what we'll be having from equation 3, t value is w 1 plus cos theta divided by cos 20 degree equals to tension here is w sin theta divided by sin 20 degree. So w will get cancelled out here. Okay, from here theta value you will solve approximately 40 degree you will be getting. Answer will be 40 degree. Okay, so answer that you will be getting is 40 degree. Okay, answer will be 40 degree. Simply just cross multiply, w will get cancel out. You will be having this sin 20 degree multiplied by 1 plus cos theta equals to this sin theta multiplied by cos 20 degree. So this sin 20 degree plus this one will be your sin 20 into cos into this cos theta equals to sin theta multiplied by cos 20 degree, like this. Clear? So the sin 20 degree equals to this part. Okay, this is your sin 20 degree. So sin theta into cos 20 degree minus cos theta, let's suppose I'm writing in this way, cos theta into sin 20 degree. So sin A minus B formula will be coming. Okay, sin A minus B formula will be coming. So sin 20 degree equals to sin theta minus 20 degree. So if I equate 20 equals to theta minus 20 degree, theta value you will be getting as 40 degree. Yes, absolutely correct. 40 is the correct answer here. Right, everyone? So just by putting 40 degree you will be getting the correct answer then also, W. Clear? Again I am telling you, not just the concepts, mathematics, okay, calculation part, all steps are what very important. First you need to know the concepts, okay, then you will apply the concept. Don't do any unit mistake, okay, calculation should be correct. So each and every steps are what required here. Okay, you have to be what accurate in every steps. Even in any one step you have done the mistake, you will get the wrong answer. Okay, so I hope this is clear, everyone. Option B is the correct answer, 42.56. Okay, let's move to the next question here. This one, and I'm expecting this one you can solve in within 2 minutes. Very easily you can solve this question in within 2 minutes. Okay, everyone, within 2 minutes you can solve. So let me just start the timer for you. Okay, start solving, everyone. Tension in the cable they are asking, tension in the cable. The very first step here is draw the free body diagram. Draw free body diagram here. Okay, just by drawing the free body diagram, after that equation of equilibrium, then you will get the answer. Okay, so I'm waiting for your answers immediately. Everyone, do it fast. Speed and accuracy, both the factors are important. Both plays a very important role. Accuracy as well as the speed. Okay, it should not be like speed is there but at the cost of accuracy. It should not happen like this. Both should go parallelly. Or if the speed is very slow, you are 100% accurate, you will not able to attempt all the questions. And if you are not able to attempt all questions, how you will get the good score? Okay, so these are very, very important points. You will get the good score when you will attempt maximum questions. And for that, speed is required. Okay, so with this live question sessions, you will get the understanding like how much speed is what required, because for every questions we'll having some given timer here also, so that you can practice with the time here. As the time is given, accordingly in that particular time period you need to solve the question. Do it fast, everyone. So time's up here. Anyone? It's a very easy problem. I don't know how much time you will take for this question, because it should ideally it should not take that much time. Simply free body diagram if I have to draw here. How I will draw? See, this is the free body diagram. Now there will be one tension here at point B, one tension here. Okay, after that there will be one tension here. Okay, this is one load which is acting here in the downward direction. Okay, this is a hinge, so horizontal reaction will also be there, vertical reaction will also be there. Now try to understand, everyone. This is the tension T, this is the tension T, right? Weight they have given as 80 Newton. This is point A. So let us assume horizontal reaction is AX, vertical reaction is AY. So this is the complete free body diagram. Okay, art craft got the answer as 74.6. A also you are telling. Okay, just wait a minute. We'll write the equation of equilibrium, then we'll see what answer you are getting, whatever the correct answer is. I hope this free body diagram, first of all, this free body diagram is clear. Okay, now what we need to find out, tension T. Which equation of equilibrium you will be using here? Which equation of equilibrium you will use? Tell me. Only unknown T is there. Better, see how many equations of equilibrium we are having. Summation of forces along horizontal direction 0, summation of forces vertical direction 0, summation of forces, summation of moment equals to 0. Total 3 equations of equilibrium we are having. Which equation I will use? Summation of moment. Okay, because if I use summation of moment, about which point I can take? About point A. A is a hinge point. About point A I will take the moment equation equating with 0. Okay, so how I will write here? Tension T multiplied by the distance. What is the distance? 5. Clear? Tension T, right? Tension T multiplied by distance 5. Okay, this is what we have. One more tension is there now, but again both will have a same sense of rotation. About this point anti-clockwise, about this point again anti-clockwise. Let us assume angle is what? Theta here. So which component I need to take? Vertical component. So T sine theta. T sine theta it will be there, but there is a 80 Newton, it will have a clockwise sense. I will take negative 80 multiplied by total distance 5, 5, 10 plus 3, 13. Correct? Equals to 0. Right, from this you will get the answer. Okay. Now try to understand tension T you will getting, but what is the sin theta value? For that they have given this information: horizontal 1, vertical 2. So never ever try to calculate the theta when the dimensions are directly given. Okay, see what triangle they have given, like this. This is 1, this is 2, and obviously if this is 1, this is 2, what will be the third side? 5. I need to write sin theta. Perpendicular upon hypotenuse. Perpendicular is what? 2 here. Hypotenuse is what? 5. Simply use 2 by 5. Correct? I hope this is clear. 2 by 5. Directly put here. You will get the answer of the tension. Correct? Yes. Summation of moment we have to use. Summation of moment we have to use. Thank you so much, homogeneous and isotropic. Correct? Art craft answer is correct. The answer given by the art craft 74.6. Option C is the correct answer here. Right? Clear everyone? Yes or no? Correct? Great. So tension we have found out. So always remember, first of all, the free body diagram is important. And after that, the correct equilibrium equation. Sorry everyone. Then the correct equation of equilibrium. Right? And after that, calculation part. Please motivate. See, homogeneous and isotropic. Okay. See, we have the examination in Feb month, right? Till how many questions, how many days we are having? Based on that, you have to plan your preparation. See, one thing should be there, clarity in your mind, like how much time is available and how much pending work is there. Accordingly, allocate your time for every subject. Okay, based on the preparation you have done till now. And accordingly give the time and try to give full length mock test that we are providing, AMTS mock test series. Because only mock test series will give you the actual feel of the gate examination, right? Sitting for 3 hours. Okay. Sir, into 10B. Yes, obviously, this is the force multiplied by the distance. Yes, correct, art craft, absolutely. Distance we need to multiply. In order to calculate the moment, force multiplied by the distance. Yes, correct, absolutely. Right, diagram nahi dekha tha angle. Ha, so see, that is, so without taking the angle, how you have solved? That is, you need to understand, without angle, how you can solve, how you can write this t sin theta component. Okay. So guys, please try to understand, whatever time is left, accordingly you have to allocate your time for every subject. See the last year weightage, okay, accordingly plan your studies. And please try to give the all India mock test series, and it will give you the actual feel of the examination. Okay, at least give 10 mock tests, so that you will have a confidence for sitting 3 hours solving different subject questions. Okay, you have to be sitting for 3 hours. That habit you have to maintain. Okay, that is very important. Otherwise, if you have not attempted mock test before the gate examination, definitely you will be facing lot of difficulty in the examination. So if you practice more, obviously the confidence level will increase. And with the more confidence level, if you are entering into the examination, your performance will definitely increase. This part you should remember. It's all about the confidence. And a confidence will be coming from the more practice. Give all your time in the practice, right? Practicing the mock test series, practicing previous year question, practicing the exercise book numericals. Clear? Okay, everyone. Now, coming to the next part, next question. Okay, before discussing the next question, I want to discuss one very beautiful concept here. And I'm telling you, from this concept, you can expect a question here. Okay, force couple system. This is very important concept here. Very, very important. Now, what is the concept here? Everyone, try to understand. So, let us assume there is a body here. Okay, and there is a force acting to it. There is a force acting like this. Okay. Force is acting at point A, force value is F Newton force is acting. Now I want to shift this force to any other point. I want to shift this force to any other point. How I can do it? What is the process of shifting that force into other point? Let us suppose the point is here, point B. At point B, I want to shift this force. So how it will be done? Yes, definitely the session, gate booster sessions will be continued for all the subjects, for all branches. We are conducting the gate booster sessions. Okay, you can just subscribe the YouTube channel and you will get all the notification. Okay, all the notification of the gate booster sessions. So please mark your calendar accordingly. Right. So this is the force acting and I want to shift this force at this point B. Now what is the process here? So let us suppose this again. Assume same body I am taking, right? This is same body only. At point A already we have drawn one force. This is the force F Newton. Now at point B, what I will do here, there is one force I will draw like this, another force I will draw like this. Both will have same magnitude as that of previous force which is applied at point A. So what I have done, same magnitude force, try to understand, same magnitude force I have applied here at point B, but in opposite direction. This is force F, this is also force F, but in opposite directions. Now a very important point here, everyone. This force F, okay, this force F and this force F will create what? A couple. Okay, tell me, this force and this force will create a couple, and what is the magnitude of the couple? What is the magnitude of the couple? It's simply the force multiplied by the distance between them. Let's suppose the distance between them is D. This force and this force create a couple. The couple can be shown by the value of the couple. Couple value is what? Force. Force of whatever parallel forces you are having. That force multiplied by the distance D. Now, so finally, how I will draw the diagram here for the body. At point B, what kind of force system we will have? Assume same body, right? Consider all three bodies are same. I am drawing a random diagram here. Assume all three bodies are same. At point B, this is the force F which is acting. Now, this force and this force will create a clockwise couple, and that clockwise couple will have a magnitude of F into D. So, what you can understand here? This single force has been converted into force couple system. This is very important concept here, guys. This single force is converted into force couple system. So the point that you need to remember is, whenever I want to transfer a force to any other point, apart from the force, there will be a couple, there will be a moment will be acting there. Apart from the force F, there is one couple formation is there, and that is what shown by a moment value F into D. Okay, whenever you want to transfer a force to any other point, this kind of system you will get. Is it clear? And whenever you are having force couple system, again you can convert into single force also. Whenever you are having force couple system, you can convert back again into single force just by taking the reverse steps. Clear? Based on this concept, we will be solving one important question, and definitely you can expect such questions in your upcoming GATE examination. Till now, this question never been asked in the GATE. I am telling you this point. Till now, GATE has never asked the question from this concept. Okay. Now, the question is this one. This question. So, what is given in the question? Try to understand, everyone. There is a triangular plate we are having. There is a triangular plate. In the triangular plate, forces are shown on A, B, C corners. Correct? What we need to do? We need to find equivalent force couple system at point A. Equivalent force couple system at point A we need to find out. And 4 options they have mentioned. So what I need to do? I need to convert all these forces into force couple system. So what you will do? Transfer this 20 kilonewton force here. transfer 30 kilonewton force here, calculate resultant value, that is the value of force, and also calculate the moment value. Based on your answer, tell me which option will be correct. Based on your solution, whatever you have solved, tell me the correct answer here. If the concept that just now we have discussed, already you told na, it is clear, then you should be solving this question very easily. Okay, very easily you can solve this question. So take 3 minutes, no issue, but you will get a correct answer, I am expecting. Okay, everyone. Just you need to transfer the forces. This 20 kilonewton transfer here A. When you will transfer 20 kilonewton force here, apart from force, moment, that is the couple value will also be coming here. When you will transfer this force here, apart from the force, couple value will also be coming here. So calculate first resultant, then the moment value at point A. At point A. Okay. This is very important question, I am telling you guys. Till now, GATE has never asked such type of problem. Do it everyone fast. Okay, 1 minute 20 seconds left. This is very important question. Okay, force couple system. How to convert a force into force couple system, and also how to convert back force couple system into single force. Right? Option D. Rahul is telling option D. Okay, we'll wait for a few people also. Rest all of you, everyone mention your answer in the chat box. Okay. Rahul is saying option D. Okay. Everyone. Okay, last 5 seconds left. Time's up. Okay, we'll see which option is correct. Option B you're telling. Art craft option B. Okay. Option B you're telling. Right. Now, everyone. First of all, when I will transfer the forces at point A, okay, let me draw the diagram here. Okay. Okay, this is the rectangle, this triangle plate you are having now. This is the triangular plate. Now I will show all the forces. 20 kilonewton, let's suppose I have transferred here like this. This is the 20 kilonewton. Already 10 kilonewton is acting at A only. Okay. And let's suppose if I transfer this 30 kilonewton at B, a very important point, they have given equilateral triangle. Okay. So, angles are what? 60 degree. This is 60 degree. This is 60 degree. Correct. this is 60 degree, right? This angle. So when you will transfer this 30 kilonewton force at point A, it will be going to this side only, along this side. This is the 30 kilonewton when you will transfer to point A, because angle here is 60 degree. Clear? So this basic thing you should be knowing. Okay, that diagram will draw here itself. Now the 30 kilonewton force like this. Okay, this is 60 degree, right? What about this angle? This is 10 is there, and this is 20 degree from the vertical. From the vertical it is 20 degree. This is 20 degree, correct? So this is 20 kilonewton they have given, right? This is 10 and another one is 30. This is 10 kilonewton. This is 30 kilonewton. So I have transferred all the forces. Apart from the forces, couple will also be coming. Sorry, C. Okay, Rahul. You are saying option C now. Okay. Okay. We'll see the correct answer here. First, okay, just you need to focus on the steps that we are taking. All the forces I have mentioned here, right? All the forces I have mentioned. Now, after that, what you need to do? See the couple value. Okay. Couple produced by all the forces here. Only this 20 kilonewton will have a moment value. Okay. And this 30 kilonewton, this 10 is already passing through A. How it will have? It will not have any moment value. Only this 20 and this 30. Now for this 30, I will first convert into vertical and horizontal component. Try to understand. 30 will be converted into vertical and horizontal. Vertical and horizontal. Horizontal anyhow passes through A only. So there will be no moment. So let me just write a summation of moment at point A. So the very first step you should do here is calculate the moment also. Option C is correct. Okay. Just wait a minute. Okay. Option C. Most of the people are telling option C. Okay. Maybe this one is also correct. Okay. So moment value about point A. First 20 multiplied by this distance. Which distance? This distance. Now how to write this distance? This angle is 60 degree. I can write 3 sine 60. This is the moment produced by this force about point A in the anti-clockwise sense. Okay, negative, positive, it's your choice. The vertical component of 30 will also create a moment about point A anti-clockwise. Let us take same side, negative, negative I have taken for anti-clockwise. Vertical component of 30 is 30 sine 60 multiplied by, what is the distance here? 3. Correct. What is the answer of moment? Everyone tell me, what is the answer of moment value? Option C you are telling, yes, 130 value, and 130 kilonewton meter first of all in anti-clockwise sense. Correct. So first we have solved this thing. Now regarding the resultant value, first write down summation of forces along x direction 0. Summation of forces along x direction we need to write. Resultant value we need to do now. So summation of forces along horizontal direction. 20 towards left, let us take negative. Towards the left, negative I am taking as per sign conventions. Towards left, minus 20 I have taken. Component of this 10 in horizontal direction will be 10 sine minus 10 sine 20 degree. Okay, minus 10 sine 20 degree because towards left it is. Horizontal component of this 30 cos 60 plus towards right it is. So 30 cos 60. You will be getting one value. Similarly, summation of forces in vertical direction we need to do it. 10 cos 20 plus 30 sin 60. Okay, the resultant value of the force will be nothing. Summation of forces along horizontal direction, clear, plus summation of forces in vertical direction. You will do it, you will get the answer. As you, most of the people will are telling option C. Yes, option C is correct here. Option C, 36.37. That is correct answer. This is the resultant value of the force. Clear, everyone? And from this example also, you can understand one more concept. To get the answer of resultant of non-concurrent force system. This is what a non-concurrent force system. Correct? This is a non-concurrent force system. How to get the resultant answer of a non-concurrent force system? We have solved a case where a non-concurrent force system is given. Resultant we have solved. So you can consider this as an example of non-concurrent force system, because again that question also never has been asked in this GATE examination. Never ever they've asked. Resultant of concurrent force system, lot of problems they have asked in the GATE examination. But resultant of non-concurrent force system, they have never asked till now. Correct? Option C. Yes, option C is correct here. Resultant answer is 36.37. Couple value is 130 kilonewton anti-clockwise. Okay, 130 kilonewton anti-clockwise. Clear, Rahul? Yes, obviously, see, we have to solve new questions. Okay, otherwise if you are solving similar type of problem only, and if in the GATE examination new question came, you will not be able to solve. That's why, to gain the confidence, the best way is to solve new quality problems. And that's what the purpose and the intention behind this GATE booster sessions. Clear? Okay. Now, going to the next problem here. Okay. Next problems will be from the truss chapter. Next problem will be from the truss. From the equilibrium, we have solved 3 problems. Okay. The last one is the new problem. Okay. You can expect that problem in your upcoming GATE examination. I'm telling you this thing. Okay. One more thing, guys. One more point I want to add here. Whenever we are writing moment, generally I've seen many people are doing mistakes. Moment, how you will write? Force multiplied by the perpendicular distance. Correct. But perpendicular to what? Perpendicular distance from the line of action of force. Perpendicular distance from line of action of force. Okay, perpendicular distance from line of action of force to the point of consideration. To the point of consideration here. Clear? Now that is we are writing, but in terms of vector, how you will write? R cross F. This is also important. In terms of vector, how you will write? The moment value, how you will write in terms of vector? R cross F. What is R? Position vector. R vector is written as x I cap, y j cap plus z k cap. Force vector is written as fx I cap plus fy j cap plus fz k cap. Clear? So this is the position vector. R bar is a position vector, F is a force vector. When you do the cross, okay, cross multiplication, cross product basically, okay, you will be getting the moment vector, right? But mostly in our calculation we are using this formula directly, okay. But as far as knowledge point of view, you should remember this concept as well. This formula you should also remember. Now moving to the truss part. Now in the truss, during the analysis we have 2 methods. Everyone try to understand. What are the 2 methods? Method of joint . This is the method 1 for the analysis. Method 2 is method of section. Now tell me in which method you are more comfortable. Tell me the name of method in which you are more comfortable, or which one of the method is more easy. Which of the method here out of these 2 is more easy according to you? Tell me. because we will be taking that method which will take less time and it will be also easy in calculation. In the gate examination, if the question has multiple approaches, we should ideally select that approach which will take less time. Because see, in the gate examination, time management is also very important, right? We have to save time in the easy problems. Okay, whatever time you have saved in the easy problems, you will invest that time in the tough problems. Because in the gate, some questions will be easy and tough. Tough requires more time. So from where you will get the more time? You have to save time in the easy problems. Section, some people is telling joint. Actually, method of section is very easy and less calculations are involved. Okay, and we will solve all the problems with method of section only. We will solve all the truss problems with the method of section. And I am telling you, if you have understood the concept here, you will never face any challenge in any of the examination. The question related to truss, you will never face any challenge. Okay. BML company. It is a PSU company, Sani. Okay. Clear everyone? So method of section we will follow, but apart from that, there is one more concept that you need to remember, because that concept will make your analysis very simple. It will make all the problems, the analysis of all the truss problems simpler. Which concept? Zero force member. So let me just tell you the zero force concept, everyone. Okay, because this concept will make all the truss analysis very, very easy. Okay, if you remember this concept. Clear? Rahul Kumar, we will discuss how to cut section also. No issue. From the numericals, you can easily understand. I will tell you the concept here, like how to cut a section during the truss analysis. BML life. See, Rajnath Sani, if you are having the opportunity, definitely you should go for it. Okay. Right? Okay. Now, see, zero force concept. Zero force concept, everyone try to understand. There are two cases here. Case number one. Just two cases you need to remember. Case number one, let us assume there is a joint in which two members are connected. There is a truss joint in which only two members are connected. Right? And let's suppose this is a case number 2. Truss joint formed by the 3 members, and out of 3, 2 are collinear. This is the case number 1, member 1, member 2. Here 3 members are there. In case 1, try to understand everyone. In case 1, truss joint is formed by 2 members, and all the 2 members, basically if I talk about all the 2 members here, are the zero force member. Zero force member basically means force in member 1, force in member 2 is 0. This is the point that you need to remember. But it comes with one condition. Every formula has its own terms and condition. And if you don't remember the terms and condition, definitely we are using that formula in some other cases where it is not applicable, and we will not able to solve the question also. And we will be getting the wrong answer. Every formula comes with its own terms and condition, and you need to remember the terms also and its conditions. What is the condition here? The joint should not have any external force and also no support reaction to it. There should not be any external force acting at the joint, and also there should not be any force, reaction force acting to it. There should not be any reaction force and the external load acting to it. If it is there without any external load, any support reaction, both the members are zero force member. How you will get zero force member? Simply apply equilibrium equation. See, why we are applying equilibrium equation? Truss is a structure. Purpose of structure is what? to bear the load. Okay, to bear the load, structure always constructed. So this structure we will always design with respect to equilibrium condition. Structures are always designed with respect to equilibrium condition. So we can apply equilibrium equations for any part of the truss. For any part of the truss we can apply equilibrium equation. I can apply for joint, I can apply for a section also, right? So if you apply equilibrium equation for this joint, okay, you will get F1 and F2 both are 0. Now coming to the case number 2. In case number 2, I've told you 3 members are connected. 3 members are connected at the truss joint. Clear? Now out of 3, 2 are collinear. See, member 1, member 2 are collinear. The third one become 0 force member here. F3 basically will be a 0 force member. F3 is a 0 force member, right? Now again there is one terms and condition. What is the condition here? There should not be external load and support reaction to the joint. That is the condition here. If it is like having no external load, no reaction, this is true. This is true. So condition we have to understand, right? Most of the time we remember the formula, but we forget what are the conditions. Okay, everyone. Very, very important part. So F1, F2 0, F3 0. These are the 2 cases of 0 force member. One more concept I will tell you, and after that we'll start the numerical. Because these 2 concepts alone will help you to solve any truss problem. 0 force member clear? Now one more concept here, concept of collinear members. Concept of collinear members. Now see, what collinear member I am talking about here? Okay, now see, this is member 1, this is member 2, this is member 3, this is member 4. This is a joint formed by the 4 members. A joint formed by the 4 members here. In this 4 members you will find 2 collinear pairs. Collinear pair 1 and 2, collinear pair 3 and 4. Whenever such collinear pairs you are finding, you can easily write force in member 1 equals to force in member 2 and force in member 3 equals to force in member 4. This is the concept you need to remember. Without doing any calculation, you should write F1 equals to F2, F3 equals to F4. Only condition is 1 should be collinear with 2 and 3 should collinear with 4. Another format of this collinear pair I can also show. See, let's suppose this is one member, okay, collinear with this member, fine. Now this member is like this and another member is like this. So in this case also members are collinear. This is a joint, member 1, member 2, member 3, member 4. Again in this case also, this is a collinear pair. Force in member 1 equals to 2, force in member 3 equals to force in member 4. Clear? Right? Now one more thing. This collinear concept is also very important. Why? Because it helps us to save time. Because when I already know about the force in 1 and 2 are equal, why I will apply the equations? Simply I will write 1 and 2 are equal. Got it? Now one more example here. Let's suppose this is one member, this is another member. This is very common in the trusses, and this one member here like this. Now this is the joint. This is member 1, this is member 2, this is member 3. Now you will say, sir, 1 and 2 are collinear, but what about 3? For 3, what actually in the trusses they will give? There is a load acting at joint. There will be a load acting at the joint. There is a load acting at a joint, and that load is collinear with the member 3. The line of action of load, take this load as P. This line of action of force P is collinear with member 3. If it is there, then I can write, first of all, force in member 1 equals to force in member 2. Force in member 3 will be equals to force, that is external load acting at the joint. These are the some standard cases that you need to remember. If you are able to remember these cases, then obviously calculation time will be very much less. Okay, less time will be required to solve any truss problem. Clear? All these three cases of collinear, all these two cases of zero force member. Till here, everyone, is it clear? Yes or no? Can we start solving question from the truss? Are you ready for the truss problem? Yes or no? Okay, can we go with the truss problem now? As we have discussed the concepts, most important concept in the truss we have discussed. With this concept alone, you can easily solve the truss problem. I can guarantee you this thing. Great, Rahul. Now, coming to the question here. This is the first question in front of you. Force in member DE they are asking. DE. P value of the force they have given as 20 kilonewton. Okay. Now, as you are asking about previously, like sir, I am having confusion in taking section. You are saying at this point, like you are having confusion in taking section, so I will tell you the point here. How to take a section. Okay. While taking a section, only few things you need to keep in mind. Okay. First, one thing, that your section should pass through maximum 3 members. That is the only main point you need to understand. See, whatever section I will use here, that should pass through maximum 3 members. And what is the logic behind that? Why is it so? Only 3 members it should pass? Because when I will cut the truss will be divided into 2 parts. Using section, I will cut the truss will be divided into 2 different parts. So, obviously, what kind of force system we will be having in the section? Non-concurrent force system. For that, equilibrium equations are summation fx 0, summation fy 0, and summation of moment 0. Only 3 equations we are having. Right? Only 3 equations we are having. So, at max, only 3 constants, 3 unknown values we can solve. At max, only 3 unknowns we can solve because we have 3 equations only. That's why we have to cut a truss with a section in such a way that the section should pass maximum through 3 members. It should not go beyond 3. Maximum it should cut the 3 members only. Now, they are asking in which member? DE. So, your section should be passing through member DE, and apart from DE, there are 2 other members are also there. Correct? 20 you are saying. Okay. We'll see what answer you are getting. Okay. First of all, the section. Now, I am drawing a section. Everyone should reply in the comment box whether the section is correct or not. Okay. DE member they are asking. I will draw the section like this. Can I draw the section like this? Can I draw the section like this? Everyone, tell me. Right? So, how I've selected the section? First, I've seen in which member they're asking the force. Correct? DE. In DE member they're asking. Okay, this is member DE. Okay, so in DE member they are asking, so I have cut the truss like this. So first member cut DF, another DE, and another is what? This member CE is cut. 3 members are cut. But if I cut it like this, if I don't use this thing, okay, if I don't use this section, what will happen? If I cut it like this, how many members are cut? 1, 2, 3, 4, 5. 5 members are cut. Not at all possible to solve them. So ideally we should cut the truss by using this section. How many members are cut? First, second and third. Only 3 members are cut. Now once you have used the section, you have divided the truss into 2 parts. Now it's up to you which part you want to analyze. It's totally up to you. Okay, it's totally up to you which part you want to utilize. Okay, analysis for which part you want to do. Now tell me one thing, everyone. Which part of the truss you want to do the analysis? Left part or the right part? For which part you want to do the analysis? Okay, that part only I will draw here. Tell me. Zero, you are telling. 0, you are telling the force in member D is 0. Left part, correct. Rahul, left part we will take, correct. You are telling 0, you are telling about the force in member D. In D member, force will not be 0. Now see, I have cut the truss. Now I will draw the diagram here of the left part here. First of all, left part I will be drawing. Okay, yes, left part. Let me draw the left part here. Okay, so there is one triangle, first of all. Like this. Then another triangle is there, AB, then BD. AB and BD is there, okay, like this. Then yes, okay. The members which are cut, I will draw with different color so that it will be easy for you to understand. Then there is one vertical component which is cut, and there is one member also cut, the horizontal one, like this. Okay. Now I've shown all the points here. Let me just rename the points here. A, then B, C, D. B, C, and this is D. Now this is the force in member D. I have assumed all the forces away from the joint. Okay, it's our choice, whatever direction we can take, but the confirmation will be there. But the confirmation will be there after the analysis. Rahul, you are saying, sir, collinear, which case collinear? At, okay, tell me which joint you are observing. Okay, tell me the joint here. Rahul, just tell me the joint name here. You are talking about which joint? Then I can easily explain you whatever the confusion you are having. Tell me the joint name. Okay, tell me the joint name here. Then force in member CE. You're talking about joint E, okay? Joint E. Now, just try to do the analysis of joint E. You are saying, okay, this is the one member, this is the another member, this is another member, this is another member, and this is what the load. Correct? In this case, this is force P, okay, this is force in member DE, this is force in member CE, force in member EF. Sorry, force in member EF, right? Now this one is force in member EG. Okay. Now, how the collinear case you are talking here? This is one additional force is there, na? Additional component of force. If it is not there, then I can say this one is collinear, this one is collinear, this one is collinear with this one. This is the additional one more force is coming, so we can't say the collinear case. If you are talking about joint D, okay, take the joint D also. You are talking about joint D, Okay, this is the one member, this is another member, this is another member, this is another member. Collinear pair it should have. See, try to understand what diagram I have drawn. That's why I am telling you, concept very important. 1, 2, one pair, another pair, one pair, another pair, one pair, another pair. Two pairs are there. But in joint E and D, as you are mentioning, joint E we have discussed, joint D. This is joint D. This is collinear with this one. This one and this one are collinear, correct. But what about this one and this one? So not possible to say. Okay, we can't say the forces will be equal. Here, try to understand this diagram. You have to focus on the diagrams here. Rahul and Artcraft, just try to focus here. These are the collinear pair, two collinear pair, concept of two collinear pair. If I attach one member here, then I cannot write F1 equals to F2, F3 equals to F4. I cannot write then. If there is one more member attached to it, I can't write then. Is it clear, Rahul? Is it clear, Artcraft? Tell me. Yes or no? Just tell me, is it clear? If it is having, like, if you are having any confusion in the collinear concepts, then again I will repeat it. Done? Okay. Now, okay, great. Rahul, confusion. Okay. Just again I will tell you. See, the collinear member concept, what I have told you, two collinear pairs. First pair is, see, first pair is 1 and 2. This is the first pair, collinear pair. Another pair is 2, 3. 3, 4. 3, 4. Pair 1, 1, 2. Another pair is 3, 4. This is a collinear pair. But if I connect one more member to this joint, if I connect one more member, then I cannot write this. Then I cannot write F1 equals to F2, F3 equals to F4. I can't write them. Okay, this is possible if there is only two collinear pairs, 1, 2, 3, 4. Rahul, now tell me, the confusion is clear or not? Done? So whenever two collinear pairs are there, 1 and 2 are the first collinear pair, another pair is 3, 4. But if it is not there and if I attach one more member, then we can't write like this. Okay, great. If it is clear, great, superb. Now coming back to our question here. Okay, just after cutting the truss with this section, okay, we need the value of reactions. Can anyone tell me what will be the reaction RC? This is RK. Please tell me the reaction value at point C. Tell me the value of reaction at point C. What is the value of reaction at point C? Everyone. And I am telling you this reaction calculation is very easy because of symmetrical force diagram they have given. Symmetrical forces are there. It is a symmetrical case. Very easy to calculate then. P by 2, no, how it P by 2? For the entire truss, if I will write the equation of equilibrium, summation of forces in vertical direction 0. This is the equation I will write for entire truss. So P plus P downward 1, 2, 3, 4, 5. Okay. 4 plus 5. This downward force should be equals to the RC plus RK. As this is a symmetrical case, so this is 5 into P. 5 into P. P value is 20. So directly I am writing 100 here. 100 equals to RC plus RK. As this is a symmetrical case, RC and RK will be equal. RC and RK will be equal. So when it is equal, the values will be what? 50 kilonewton. 50 kilonewton. Okay, RC value will be 50 kilonewton. Is it clear? Summation of forces in the vertical direction for entire truss. This equation has been written for the equilibrium of entire truss. Summation of forces in vertical direction, RC plus RK equals to 100. Symmetrical diagram, both will be equal. Each one of the value of reaction will be 50. Correct answer, Rahul. Correct, super. Now, RC value is clear. Okay, now we will mention here RC 50 kilonewton value is the force. This is what the P, how the P they have mentioned in the downward direction. Okay, this is the value of P which is acting. Apart from that, any other forces involved? No. This is the left part of the truss that we will obtain after drawing this section XX. If I cut the truss with this section XX, the left part will be drawn like this. Left part will be drawn like this. Is there any confusion in the free body diagram or the diagram that I have shown for the left part of the truss? I hope it is clear, very easy. Correct. Now, what we need to find out? DE. Question is force in member DE. And I am telling you one thing here. In order to calculate force in member D, only one equation is required. With only one equation, we will be getting the answer. With single line. With single line, we will get the answer. Okay, everyone. With single line. Okay, there is not at all like 2-3 lines. If you are taking 2-3 lines, then you are not understanding the main concept of method of section. In method of section, almost 90% numericals, more than 90% numericals, you will see answer is coming in single line. Absolutely, Rahul Kumar, absolutely correct point. Moment 0 we have to take, but which point? About which point you will take? About which point you will take the moment? Saurabh is saying A. Superb, Saurabh, superb. So at point A is the, we will be taking what? Moment 0. See, now you need to understand why Saurabh has said A. That is the question. Rahul is saying about point C. See, that's what you need to understand. Why we have to take about point A. At point A we need to take. People are saying about C. Okay, you are taking the name of C also. Okay, I will tell you why C is not possible to take. Why we need to take about point A. See, the one point you need to write first of all, we have always remember we have 3 equations of equilibrium. Summation of forces vertical, horizontal and summation of moment. So any of the 3 equation I can use. As I told you, is any of the 3 equation I can use and answer should come up in single line. Answer should be coming in single line. So now summation of moment, as many people are saying, summation of moment about point C you should take 0. Okay. If I take moment about point C 0, first of all 50 kilonewton will not be coming because at point C 50 kilonewton is there. Okay, no problem. F into DE, there is a moment because of this force. What is the distance? Distance panel 6 meters. Okay, 6 is the value. Okay. Let us suppose clockwise it is making. What about the force? This force, which force it is? It is cutting DF, force in member DF. What about the moment here? Force in member DF, that this force DF will produce moment about point C. What is the moment? You need to write it. Already DE is unknown, DF is also unknown. How you will be able to solve an equation with 2 unknowns? How is it possible? Is it possible to solve the equation where 2 unknowns are there? I think all of you miss one point. The moment because of DF. DF will also have a moment about point C, yes or no? df will also have a moment about point C, and if it is having the moment, then two unknowns. So it is not possible to calculate the equation with two unknowns. That's why we can't consider point C for taking moment 0. Is it clear, Rahul? C is not the correct point where we have to take moment. Superb. Okay, clear. Why the point A we have to take? Why we need to take point A? Okay, because when you will take point A, only single unknown will be there. Which unknown? DE. Because the moment because of DF, as force DF line of action is passing through point A, there is no moment because of DF. Correct? Because of DF force, there will not be any moment because DF line of action is passing through A. Second, line of action of force CE is also passing through point A. So there is no moment. BC is a zero force member. Let me check. BC is a zero force member. Try to understand a very important point. You told BC is a zero force member. Yes, this is a truss joint. Okay, this is a truss joint formed by two collinear pairs. Third one, zero force member. Correct? Yes, that is true. Okay, but you need to understand why we need to take point A. Because moment because of this unknown value which we don't want, this unknown value which we don't want, only this unknown I want in our equation. Only this one should be there. Okay, try to understand. Only this one should be there. So if it is there, okay, only this one should be there. So point A we need to take then. Point A, moment. First of all, force DE, moment about point A. What is the distance of force DE from point A? This one is 6, this one is 6, 12. Okay. There will be 50 kilonewton force is also there. What is the force of 50 kilonewton? This one is 6 in opposite direction. So 50 into 6 it will be there. Force in member DE you can easily calculate then. What is the answer? What is the answer then? Done. Now it is very easy. 25 is the answer. Correct. Absolutely. Okay. In method of section, please try to understand. All the question you can solve in a single line. I'm telling you. Till now, whatever question come in our GATE examination, both in mechanical and civil, all the questions are possible to solve in single line. Just you need to understand which equation of equilibrium you have to use. If you are using correct equation of equilibrium, you will get the answer in single line. So while writing a moment specifically or using any equilibrium equation, remember one thing. I need answer of DE. Okay, I want answer DE. So for me, this one, DF and CE should not coming into the equation. This other unknowns should not come into my equation. That point I need to remember always. While writing the equation, I need to know, okay, this force DF, this force CE should not come into my equation. Then only I will get the answer in single line. If it is clear, now concept is completely understood. In the next problem, you should be solving question within 2-3 minutes, right? Now, force in member GD. Force in member GD. Okay, for this I will give you 3 minutes. Okay, I will give you 3 minutes and I want correct answer from everyone. Correct answer from everyone. Okay. Force in member GD. Section you can draw like this. First member, second member, third member. Okay, right. 3 members we are cutting with this section, so it is okay, fine. Force in member GD. Again, single line problem, everyone. With single line, single equation, you will get the answer. Do it fast, everyone. 1 minute left. Draw the truss. Okay, we have used the section XX. The left part you can do the analysis. Force in member GD. $57. Okay, 5. Okay, you are saying 5. Aspirant is saying 5. Okay, we'll see. Everyone, other people also mention their answers. Time up. So you told answer 5. Okay, I'm waiting for other people to respond also, then we'll start solving. 20 you're saying. Okay, so we got two different answers, 5 and 20. Meanwhile, if anyone is solving, please keep on trying and mention your answer in the chat box. Okay, meanwhile I will just draw the diagram here for your understanding. Okay, left part already I have shown the section. I hope everyone is okay with this section. We will take the left part, right part for the analysis. Okay, now see. This is force in member GF. This is force in member GD. Force in member CD. Let me write down the names as well. E, this is joint D, this is F. Okay, this is F. On the F there is 5 kilonewton force as well. Right. Okay, all the points we have mentioned. Right. There will be one support reaction also at E. Is it clear, everyone? The diagram is clear for the given truss. Now tell me one thing, which equation you will be using? Again, we have 3 equations of equilibrium. Again, see, steps are very easy. Write down all 3 equations. Not writing, actually you have to think in your mind. We have 3 equations. One by one I will try to apply all 3, and any one of these 3 will help me to get the answer. Summation of forces horizontal, can I apply? I will see first of all. See, which unknown I need to find out here? GD. This is the unknown that I want to find. If I take horizontal components 0, GD component will be coming, okay fine. But GF, again one known unknown, its horizontal component is also coming. Two unknowns in the equation, not possible to solve. I will not use this equation. Now coming to the second equation of equilibrium. Summation of forces in vertical direction. GD vertical component is coming, okay fine. GF is there, its vertical component will be there. Yes, obviously, because it is inclined. So again, that GF value I don't know, GD again I don't know. Two unknowns in one equation, not possible to use. Now only option left for us is summation of moment. Now next question is, sir, about which point I need to take the moment? While taking moment, you need to understand only one point. You have to select that point at which all unknown values like GF and CD. GD we have to find out, it should be there in the equation, but I don't want GF force and CD force in my equation. So I need to select that point where the moment of GF and CD is 0. Yes, absolutely, Saurabh, correct. See, all the answers Saurabh has told correct here. Answer that question that I'm asking it, like about which point you need to take the moment? E. Yes, absolutely, E is the correct point. And why is it so? See, remember the condition, you have to select a point for moment in such a way that other unknown values like GF and CD should not have a moment at that point. So if I see point E, GF force has a line of action passing through E, CD force line of action passing through E. So both the forces, GF and CD forces, will not have a moment value at point E. So I will be taking which point? E only, and there is no need to calculate RE also. Again in this question there is no need to even calculate RE value. Are you getting the point? So you should not be in hurry. I have seen many people, okay, whenever the trust question comes, immediately they will start solving the support reaction first of all. Because in the notes they are writing step number 1 is calculate the support reaction. Just think about it, whether it is required or not. Okay, that's why I never write like this, step number 1, step number 2. Specifically in method of section. Okay, whenever truss is given, many people start solving the support reaction. Then they will see what actually they are asking. So the point is, you need to understand force in GD member, then see the truss. Is it required to calculate RE value? No. If a person calculating RE value, then he comes to know there is no requirement of RE, then obviously he has wasted some 1 or 2 minutes in the calculation of RE reaction. Right? So please understand, while taking a moment, you need to know other unknown should not coming into your equation. That's why point E we have to take. Now at least tell me the answer. Saurabh, you have told me the correct point. Tell me the correct answer here. The answer of the force in member GD. Everyone, people, moment value we have to take about point E and calculate the answer of force in member GD. Everyone, do the calculation. Moment about point E we have to take. Apply the equation and tell me the answer. Force in member GD. Okay, do it everyone fast. Moment about point E we need to take. So GD vertical component will be coming. There is 5 kilonewton which will be coming. Only 2 forces are involved. Tell me the answer in force in member GD. Force in member GD. 18. No, it is not correct. See, you have told me the correct point about which we have to take moment, and still you are getting wrong answer. Right? So maybe you are doing mistake in taking this moment values, right? You identified the correct point, but you are writing the equation, in wrong way and getting wrong answer. 7.32 art craft is saying 7.32. No, 7.32 is also not correct. Why you are doing mistakes in writing moment? 7.32 you are getting. Okay, see, moment about point E. Let us suppose this is the angle theta, right? Force in member GD, sin theta I need to write. Force in member GD, vertical component sin theta. It will have a clockwise moment at E and 5 kilonewton will have anti-clockwise. So I will write directly 5. Distance also we need to multiply. What is the distance from here? 2 meter. Okay, equals to 5 multiplied by 2 meter. Okay, fine. What is the sin theta value? Let me write it here itself. Sin theta. See, this is the angle theta we are talking about. So perpendicular is what? 3, base is what? 2. Correct? Perpendicular is 3, base is what? 2 here. So perpendicular upon hypotenuse is the sin theta. Perpendicular is 3. Hypotenuse will be under root 3 square 9. 2 square is what? 4. 9 plus 4 it is. So instead of writing sin theta, I can write force in member GD multiplied by 3 by under root 9 plus 4 multiplied by 2 equals to 5 into 2. Correct? Now I hope you will be getting correct answer. Tell me the correct answer now. Rahul, Saurabh, what will be the correct answer now? So again one more thing, I've seen they will calculate theta, then again they will write sin theta. Whenever dimensions are there, simply write sin theta, cos theta in the dimension format. Yes, now you got the correct answer. 6.02, approximately 6.02 it will be there. 6.009 approximately it will be there. 6.009. Okay. 6.009 2 kilonewton. This is the approximate answer finally. Done. See, we have to be very careful in the calculation part, everyone. Knowing every concept, okay, knowing the correct relation, every step you have taken right, but in the last you have done the calculation mistake. Okay, it will waste the whole effort that you have done for that particular numerical. So we have to be very careful in the calculation part, and also please be habitual with the virtual calculator. Yes, correct Rahul. Yes, aspirant, craft, all of you, now you are getting correct answer. You have to be habitual with the virtual calculator. You can install an app of this virtual calculator in your phone also from the Play Store. So please keep trying, okay, please keep trying the questions, whatever numericals you are doing with the virtual calculator only. Sir, collinear concept. In which case collinear concept you are saying? Again, how I can use GD with collinear concept? If I have to find out GD, how I can calculate GD with collinear concept? For your understanding, collinear concept I can apply here. GF member, FE member collinear, FD member and 5 kilonewton are collinear. Rahul, please focus here. At joint F, GF member, FE member are collinear, and this FD member is collinear with the line of action of 5 kilonewton force. Is it clear? So this FD member will be equals to 5 kilonewton. GF and EF. GF and EF, that's what I've told you, na. See, always, okay, Rahul, please tell me the joint, which joint you are observing. Where, see, whether zero force concept or collinear concept, you have to look at the joint. Tell me the joint name you are talking about. Joint name. Tell me the joint name. If you tell me the joint name, then it will be very easy for me to understand what actually the concern you are having regarding this collinear concept. As I told you, collinear concept, from collinear concept I can write force in member FD as 5 kilonewton. Clear? Is it clear now? Force in member FD I can write 5 kilonewton. Similarly, with collinear concept I can write force in member HB as 5 kilonewton. Why? Observe the joint. Please remember one thing, whether it is a zero force concept or whether it is a collinear concept, we need to focus where? Joint. Joint H I am observing here. Joint H. HA member collinear with HG collinear. HA member and HG member collinear. HB is collinear with the line of action of 5 kilonewton force. So force in member HB equals to 5 kilonewton. At joint F, let me see what you are telling. At joint F, at F 5 kilonewton are not. Actually, this your comment is not completely visible to me. Some logo is coming. Just give me a minute. Okay. You are saying FD and GD. FD and GD. So FD and, see, if you talk about FD, GD, if I talk about joint D, CD and D are collinear, but GD and FD are not collinear, na? At F 5 kilonewton are not there, then 0. Yes, absolutely correct, Rahul. If 5 kilonewton is not acting at F, this FD value will be 0. Absolutely correct. Now I got your point. You are absolutely correct. At F 5 kilonewton is not there, then FD become a zero force member. FD become a zero force member. How? A joint formed by two collinear pairs. Okay, a joint formed by three members first of all, 1, 2 and 3. Out of 3, 2 are collinear, third one becomes 0. But condition is joint should not have any load and also there should not be any support reaction. Clear? Okay, tell me in this particular example only, tell me the zero force member, everyone. Tell me the zero force member in this particular question. Which member is a zero force member? In this particular question, which member is a zero force member? No one. How is it possible? There is one zero force member. There is one zero force member. Correct, absolutely. Joint C is formed by 1, 2 and 3 members. Out of 3, 2 are collinear, third becomes 0. And also the joint is not having any load, not having any support reaction. Correct. CG is correct. GC correct, absolutely. this was our section that we have drawn. Now I hope you are getting the confidence in the trust problems, right? Let us solve one more problem. This one. This one I am expecting everyone to solve, okay, within the given time. Force in member CB. Force in member CB they are asking. Do it fast, everyone. Method of section we need to use again. First, cut the truss using a section which has to what pass through CB, because CB is the unknown value that we want to calculate. After that, see which equilibrium equation you have to use here, and what is the concept behind selecting the equation of equilibrium. In that equation of equilibrium, only one unknown should be there. If it is having two unknowns, we can't solve. Okay, last 1 minute left, everyone. Last 1 minute. Force in member CB. So simply this will be our section. Okay, last 10 seconds. 25. We got two answers. Okay, 25. Third answer we got. Time up, everyone. Okay, three answers we got, like 25, 25. Okay, we'll see which answer is correct here. So this is the section that we have to use here. Okay, now the truss. Let me draw the truss for you. Now the members, the members cut by the truss is what? CB, first member, this one, then EB, and finally EF. So directions you can assume, it's your choice. Whatever direction you want to assume, you can assume. There is no problem in assuming direction. But if answer is positive, then only your assumed direction is correct. If answer is negative, then your assumed direction was wrong. You have to change it. Okay, just reverse the direction. D, this is point C, this is point E. Okay, so this become force in member EF. This become force in member EB. And this come force in member CB. Correct. Okay. Now forces also I need to mention. 10 kilonewton at 6, 5 kilonewton at D. There is a force in member at E also. Correct. Now see everyone, in order to calculate force in member CB, we have, okay, how many equations of equilibrium? 3. Now tell me which equation you will use. Summation of force is 0, summation of moment finally 0. These are the 3 equations. First I will see summation of forces along horizontal 0. Okay, obviously first summation of forces horizontal 0, but my CB is a vertical. Obviously it is not coming in our equation, so there is no point in using first equation of equilibrium, not possible. Second, CB vertical, so definitely it will be there. Apart from that, EB, EF, all 3 will be coming into the equation, not possible. Only last option left is taking this summation of moment. But again, next question will be about which point. Tell me the value or the point where we need to take the moment. Tell me the point where we can take the moment. The point we should take the moment. Tell me. About which point you will take the moment to get the answer. We need to calculate CB. Other 2 unknown should not coming into the equation. If you are saying D, so then understand, if I take the moment at D, the moment because of EB, moment because of EF will also come into the equation. E is the correct answer. Okay. Yes, Saurabh, correct answer is E. Aspirant E, correct. Answer is correct, E. So always Rahul Kumar, E also correct. I've told you before understanding like about which point you want to take, you have one thing in your mind always. We have to select a point where all the unknown value will have a 0 moment, except for which we want to calculate. Clear? So point E, because at point E both the force moment like EB force and EF force moment value at point E is 0. Got it? Okay. Now moment at point E I need to take, then write down the equation. 5 into 4. Thus 5 will create a clockwise couple and CB will create an anti-clockwise. 10 is also passing through E, again there is no moment. So CB into force in member CB into the distance. What is the distance? 4. Sorry everyone. Force in member CB equals to finally 4 will get cancelled at 5. Right. 5 kilonewton is the correct answer. Yes. Saurabh has mentioned the correct answer. Great. Clear everyone? So again see what calculation required. Very easy. Not even you don't even need the calculator also. So truss problems are very easy if you use method of section, and with method of section 2 concepts are very important. What are those 2 concepts? Zero force member concept and collinear pair concept. Yes, aspirant, correct answer, absolutely. 5 is the correct answer. Yes, Rahul Kumar, 5 is the correct answer. Superb. Again, can you find any zero force member here? Can you find any zero force member here? Is there any zero force member in this particular question? Tell me the name of zero force member if it is there. Art craft. Yes, FB is 0. Correct. Because this joint is formed by 3 members, and out of three, 2 are collinear, third one becomes 0, and at joint no load, no support reaction. Yes, Rahul Kumar. Yes, Saurabh. The FB is 0 force member. Clear? Now tell me, is the truss related problems are clear? Is there any doubt in the truss part, or any conceptual doubt is there? So you can ask also right now. In the truss concept, in truss chapter basically, if at any point of time you are facing any difficulties like regarding any concepts, so you can straightforward ask the question in the comment box, in the chat box basically, and I will try to help you out in that concept also. Done? I hope it is clear, because we have discussed all the concept which is required for numericals. Okay, we have discussed all the concept which is required for numerical. What are those concepts? Again revise this thing. Collinear concept, first collinear concept, then this zero force concept. So while solving any truss related parameters, you should always keep these concepts in your mind, because if you know these concepts, then the question become very easy for you. That particular numerical become very easy. Got it? Now truss chapter we have done. Now we will move to the next topic. Friction. Very important, both in mechanical as well as civil. Very important. So usually truss questions you will see, and after that friction. Very important. Specifically in mechanical civil, if you see friction, very like conceptual question they are asking. Last to last year there was one MSQ question also asked. Okay, we will solve some MSQ question from this friction topic. Okay, so be ready for the MSQ problems also. Just one point I want to tell here, like regarding friction. Friction force, everyone will write friction force is what? Mu into n. What is mu? Coefficient into coefficient of friction, and n is the normal reaction. Done, sir. Yes, Rahul, you have to see what I am telling you. Just solve all PYQ with method of section. Automatically you will gain the confidence. Just solve all the PYQ, previous year question, with method of section. All the question you can solve it now. Okay, after doing these 3 numericals, all the problems of the truss become very easy. Just solve PYQ. Okay, and then later you can come and comment also, sir, now I am able to solve all PYQ. And still after this session, if you have any doubt, you can mention in the comment box. I will reply as soon as possible. Okay. Now friction force, if I ask anyone what is the friction force, directly everyone will tell mu into n. Correct. But this is not friction force. This is a maximum frictional force value. This is the value of maximum frictional force, right? And this mu is coefficient of static friction. Coefficient of static friction it is. So this is the maximum frictional force, and when it will be acting? For impending motion condition. Not always applicable for impending motion condition. Applicable for impending motion condition. Now, sir, what is impending motion condition? Impending motion condition correspond to that situation, okay, where the body is on the verge of moving. It is on the verge of moving, or we can say it is just about to move. It means on the verge of, moving, or even I can write sliding also, no issue. On the verge of moving. Clear? So when it is confirmed that the body is under impending motion condition, that is on the verge of moving, then we can apply this formula. Not always it is applicable. We have to first confirm the condition, then we can apply the formula. Clear? Now one more thing, direction of friction. always people are confused with the direction of friction. Just remember one line. Friction force opposes the relative tendency of motion, that you have learned so many times in your classes. Friction force opposes the relative tendency of motion, correct. But how to find the relative tendency of motion? Okay, simple example I will tell you, from that you can easily understand. Okay, before taking the numerical, we'll see this case. This is the block, okay. On the block, this is the force P. What you need to do, draw the free body diagram. Free body diagram of the block I will draw like this. This is the force P. There will be some normal reaction force. This is some self weight. Now, you need to identify the relative tendency of motion of the block. How you will identify? You have to observe the body from this plane. Okay, you are standing on this plane and observe the body. Okay, the body with which it is having a contact, on that body you have to stand and observe the motion. I need to observe the motion from where? From another body with which it is having a contact. It is having a contact with the plane. So you have to be on the plane, then observe the block. Obviously, block will have a tendency to move towards right. So friction force opposes this tendency by applying a friction force like this. Is that clear? Yes or no? Very basic point. So relative tendency of motion, how you will find? Just see the motion of a body from that surface, from that body with which it is having a contact. From that body you will observe it. Now, one more point that you need to understand here. If it is clear, now next we will move on to one more concept here, very important. If your applied force is less than maximum frictional force value, P is the external force which is creating the tendency of motion. If it is less than the maximum frictional force value, body will be under static equilibrium. Body will be under static equilibrium. And if it is equals to maximum frictional force value, then we can say impending motion, on the verge of moving. This is known as impending motion. Clear? Third, if P value, applied external force value, is greater than your maximum frictional force value, the body will be actually moving, and which is known as dynamic condition. And in that case, frictional force value will be equals to coefficient of friction multiplied by n, but there is a small change. Coefficient of friction will be the kinetic coefficient of friction, which is generally having a less value compared to static friction. Compared to static, mu k will have a less value. Remember this concept. Now, if this much part is clear, we'll move to the numerical. Okay, now everyone try this particular numerical. I will give you 3 minutes for this one. Again, easy problem, and related to that, there was a question asked in previous year. So I hope you will be able to do it. Sorry. What will be the answer, everyone? Determine the minimum coefficient of static friction at A and B so that equilibrium of supporting frame, this frame, is maintained regardless of the mass of cylinder. Mass of the rod we need to basically neglect here. theta angle is given as 30 degree. Again, draw the simple free body diagram. You can consider joint A or B. A or B, any joint you can consider. The contact point, not the joint, contact point. For that, what are the forces? What will be the forces? You have to understand first of all. Then draw all the forces and apply equation of equilibrium. Okay. Do it everyone first. Last 1 minute. Last 1 minute, guys. Zero 0.58. Okay. First answer we got 0.58. Time up. See, you can consider any contact point A and B, any point on the rod A or B, whatever your choice. Let us take B here. Okay. So there will be, see, this is AC of the rod and this is CB of the rod. Okay, CB part and AB part. Now what happens? There will be force passing through that rod. There will be one normal reaction at this contact point and there will be a friction point. Now try to understand here. Because of this weight, what will happen to this contact points A and B? It will try to move. Correct? Because this is what a weight it is having acting on this joint C. Because of this weight, this contact points will try to move. Where it will try to move? B towards right, A towards left. Clear? First you need to understand the tendency of motion. Because this is what some weight acting over it. B will try to move towards right and A will try to move towards left. Once this motion is clear, now we can easily identify direction of friction force. As B will try to move towards right, friction force will try to oppose that tendency by applying a friction force at B. This is the normal reaction NB, and through the rod, let's suppose the force is F, which part is there? CB. CB it is. Friction force will be coefficient of friction multiplied by normal reaction NB. Coefficient of friction multiplied by normal reaction. Now determine the minimum coefficient. So for that minimum coefficient, okay, we are assuming what condition? Impending motion condition we are assuming here. We are assuming impending motion condition, which means on the verge of moving. It is on the verge of moving. Not actually it is moving, but it is just about to move. So these are the forces I've mentioned. Okay, now from the vertical it will have angle theta. It will have angle theta. Clear? Now equation of equilibrium I need to apply. Equation of equilibrium. first equation of equilibrium I can apply here. Summation of force along horizontal direction 0. Okay. So this CB sin theta, what is the theta value? 30. So sin 30. Okay. It is towards right and this friction force towards left. So both will be equal. So directly I am writing FB. FB value is mu NB. Okay. So this is the point we got from the summation of force along horizontal direction. Now vertical component I can relate also. Okay. First I will write CB value. CB value equals to mu into NB divided by sin 30. So this is the equation number 1. Now summation of forces in vertical direction equals to 0. So FCB cos 30 degree. Okay, FCB cos 30 equals to NB. So from here I can write FCB equals to NB divided by cos 30. This is equation 2. Comparing equation 1 and 2, because CB value both will be equal to each other. Okay, so I will equate both the values. NB will get cancelled out, mu value will be getting. Okay, just I will write next from equation 1 and 2. Mu NB by sin 30 equals to NB by cos 30. Okay, sorry. Everyone. So we got NB by cos 30. So from here you will get the value of mu. Okay, sorry for the inconvenience here. Actually I suffered from the cold, that's why continuously I am sneezing. Yes, 0.577.58 approximately. Yes. Okay. But if, see, this is the one way of doing the problem. This is the one way. Another way is, which is more convenient and it will be like less time consuming. What is the name of that method? Lami's theorem. Lami's theorem, right? So for that you need to understand what is Lami's theorem. Okay, I think everyone has solved and got the answer 0.57 approximately. You will be getting this as answer. Okay, now this question we can also solve by Lami's theorem. Just a small point I will tell you, and it will help you in most of the problems. Okay, so please give proper attention here. Okay, because this is very important. In some of the question with Lami's theorem, question is like it becomes very easy in the calculation part. Sometimes what happens, no, like here we have to write two equation, then we have to solve. With Lami's theorem, with single line we will get the answer. See the magic here. So let me just draw again this diagram. Okay, before drawing the diagram I will tell you one point here. First of all, the condition of Lami's theorem, terms and conditions. First condition, body should be in equilibrium. Body should be in equilibrium. Second thing is what? Only three forces are there. Only three forces are acting. These are the two conditions. Clear? Now, very important point. See, body acted by three forces, F1, F2 and F3. Let's suppose like this. Angle opposite to F1 is alpha, angle opposite to F2 is beta, angle opposite to F3 is gamma. Clear? Now, because of the Lami's theorem, I can directly write F1 divided by sin alpha, F2 divided by sine beta, F3 divided by sine gamma. Correct? Clear? This is the equation. Now, this is the direct formula. Okay, there is a derivation involved. Derivation is again very small. We have to apply what? Simple concept here. Vector addition, because all three forces acting on the body, but body is under equilibrium. Apply the vector addition. You will get the answer. Simply sine rule. In nutshell, if I have to tell, it is a nothing but the outcome of sine rule. Right? So whenever body is in equilibrium and three forces are acting like this, you can easily apply this relation. Now, very important point, the conclusion of Lami's theorem here. Bodies under equilibrium, only three forces are acting, then three forces must be concurrent. Three forces must be concurrent. What do you mean by this concurrent forces? The point of application is same for all three forces. All three forces have a same point of application, or all three forces are passing through same point. This is the important conclusion I am telling you, very, very important. I will show one example also. With just this information, question becomes so easy that another person is solving in 2 minutes, you will be solving in 30 seconds. Okay, I will show you one example also related to that. So whenever this is confirmed that body under equilibrium, second, only three forces are there, then definitely all three forces must be concurrent, which means point of application is same. Correct? And this formula. Clear? Now, as far as this problem is there, let me just again draw the diagram here. This was force in CB, this was FB, and this was your NB. FB is mu NB. From the vertical angle was 30 degree. Now, body under equilibrium condition, everything is under equilibrium condition, right? Now, there are what? How many forces? Three, concurrent only. Correct? Now, concurrent forces, apply the Lami's theorem. We will apply like this. FB, which is nothing but, better write, instead of writing FB, I will write mu NB. Mu NB is FB value. Angle opposite to FB is this much. What will be this angle? 180 minus 30, that is 150 degree. So I will write sine 150. Then I will write angle opposite to NB. Angle opposite to NB is 30 plus 90 degree. That is sine 120. Now NB will get cancelled out. Correct? You will get the answer from here. Mu equals to sine 150 divided by sine 120, which is 0.57. Clear? Yes or no? Is it clear? Nice handwriting. Thank you so much. Okay. Now, this concept will save your time. Okay. Now, moving to the next part. This question. This is the question. Now, everyone try to solve it. This question. Okay, this is very easy problem, and I am telling you, first I will solve with the normal approach. Second, we will use the short trick here. Okay, second approach will be based on the short trick, and that will take hardly 30 seconds. Hardly 30 seconds it will be taking. So first everyone should try. I will give you 2 minutes here. Do it everyone fast. Yes. Determine the smallest value of mu at A for which equilibrium is maintained. You got 0.4. Okay. Uh, 0.4, I don't think so it is correct. Just check the calculations. Please check your calculations. Two point three. How is it possible? Coefficient of friction cannot be greater than 1. 10 seconds left. 2.6. No. See. First, the free body diagram. 0.23 you got now. Okay. I think so it is correct. Let me check. First, free body diagram I am drawing here. See everyone. At B there is no friction, so only NB will be coming. But A friction is there. How the friction force will be acting? Towards right or left? In which direction? Towards right? Correct. Because the tendency of motion of point A on the rod will be towards left. So towards right will be the friction force like this. Clear? Okay. Next is what? The weight. That will be there. Okay. Now try to understand. Coefficient of friction is 0 at B. So that's why only normal direction is coming, no friction force. Apply equations of equilibrium. First of all, summation of forces along horizontal direction 0. Right? Because this is non-concurrent force system, right? Okay. If I apply horizontal NB and FA, so NB value equals to FA, which will be written as mu NA. Okay. Next, summation of forces in vertical direction 0. So only W and NA is there. So NA value equals to W. Okay. Then third, summation of moment. Wherever you want to take, you can take. Okay. Where we should take. Okay. Where is that point? Let us suppose any point you want to take, you can take it. But let's suppose I am taking at point A. At point A I am taking W. Okay. Remember, W is nothing but NA only. So W will have a moment about point A. Let me write point A and point B. W will have a moment about point A. So instead of writing W, I will write NA. Okay, because W and NA both are equal. So instead of writing W, I am writing NA. So NA multiplied by just half of 2.5, that is 1.25. That is clockwise moment, and NB will have anti-clockwise moment. So I will equate both the moments. NB, instead of NB, I will write mu NA. Okay, instead of NB, I will write mu NA multiplied by the distance. What is the distance here? 6. Okay, distance is what? 6 it is given. Clear? Distance is directly 6 is given. Now from here NA will get cancelled out and you will get the answer of coefficient of friction from here easily. What answer you are getting? .208. 0.20. Exact answer will be 0.208. Correct? Okay. So this is the one way of doing the problem. This is the one way of doing the problem. But what is the short trick here? Okay. What is the short trick involved here? Okay. Try to understand. This one every people will do it like this. They will get the answer 0.28. What is the short trick? Now please be careful. Okay. Now understand here. This is what we have short ladder AB. This is NB. This is NA. This is FA. Clear? And this is what W. I told you whenever three forces are there and body is under equilibrium, according to Lamy's theorem, all three forces must be concurrent. Body under equilibrium, only three forces are there, then all three forces must be concurrent. First force, second force, but here are total four forces. Actually, I can convert friction and normal forces with their resultant. Okay, I can solve the resultant value for friction and normal, right? Instead of writing friction and normal, I will write a resultant value. Okay, this is very important concept. Resultant will be like this. FANA, resultant value R, let's suppose. The resultant value at A. Resultant will make an angle with the normal, which is known as angle of friction. Yes, Saurabh Upadhyay sir will take the mathematics. Definitely you will be taking the mathematics. Okay. So friction at point A and this is the normal reaction at point A. So please try to understand everyone. This is the reaction we got. Resultant value. Resultant of friction and normal. Okay. Try to understand. This is friction and normal. The resultant answer is R. So resultant value, resultant whatever we are having, resultant will make an angle with normal, which is known as angle of friction. Okay, which is known as angle of friction. Okay, definitely TOM also I am taking. Okay, theory of machines gate booster session I am taking. Okay, so be prepared, be ready for that session also. Now just focus on the engineering mechanics as of now. Angle of friction phi s. Now I can convert, as I told you, there are only three forces, not the four. How? Three forces like this. NB, W at the center. Now, this is what the resultant RA. Only three forces, body under equilibrium. Body is under equilibrium, all the three forces must be concurrent, which means the line of action of all the forces will be passing through same point. Okay, how is it possible? See. First of all, this is the line of action of W. From the center it is passing. Line of action of NB. Right, line of action of NB I have drawn. Now line of action of RA also I will draw, and it will pass through in such a way that, okay, it will pass in such a way that all the three lines are passing through one point. All the three line of action of the forces will be passing through one point. Yes or no? Because body under equilibrium, okay, body is under equilibrium and only three forces. All has to be what? Concurrent forces. All three forces. Now see this value NB. Just I will mention NB here. This is W. This is what? Reaction R. Okay. Now one thing, see, in starting you need to understand how to draw the diagram, then it's become very easy. This angle, try to understand, this angle is what? Angle of friction, because resultant from the vertical is making angle of friction phi. Now if you try to understand this triangle is what? This is 1.25, okay, this is 1.25, and what is the vertical height? this vertical height is what already given as 6. So I can write tan theta, tan of phi equals to perpendicular is 1.25 divided by 6. So tan phi value will be approximately 0.20. Okay, what answer we got? 208. This answer. And coefficient of friction is what? Tan of angle of friction. Coefficient of friction is nothing but tan phi only. Coefficient of friction is nothing but tan phi, 0.208. So with just a single line you got the answer. See, actually solving this question with single line will take only 30 seconds, but at least you have to know how to apply the Lami's theorem here, how to use the conclusion of Lami's theorem, how to draw the lines. Okay, so this much speed will be coming when you have solved enough number of problems. Okay, I hope, is it clear everyone, how we have solved directly coefficient of friction with single line. There is no need to apply equation summation fx, summation fy, then summation of moment. There is no requirement of this much calculation. Directly we got the answer like this. Clear? Yes or no everyone? Tell me fast. Then we'll move to the next numerical here. Clear? Done. Okay. Now, next problem here. Again, very important problem here. Okay. This kind of problem you can expect in GATE examination. Okay. Just try to solve this one fast. Everyone. 20 Newton block A. So for block A weight is 20 Newton and for B it is 30 Newton. It is in an inclined plane. Coefficient of static friction is 0.5 between A and B, but there is zero coefficient of friction between block B and the inclined plane. Determine the coefficient of friction for which motion is impending. Okay, determine the coefficient of friction for which motion is impending. Okay, I think now it is audible. So FBD of first of all block A we have to draw. Okay, FBD of block A. In the question theta we have to find out. Question is theta. What is the angle of theta? Inclination angle we need to find out so that equilibrium can be there. Equilibrium, why I am telling equilibrium? Because impending motion condition is associated with what? Equilibrium condition only. This impending condition means what? Equilibrium, right? So for that condition, what is the angle theta they are asking? So step number 1 is draw the free body diagram, right? Draw the free body diagram. So first free body diagram of block A. So block A we will draw first. Okay, so this is the block A we are having. This is the tension we are having. This is the tension force. Okay, this is the tension value, correct? And what else we will be having? Weight. Okay, now very important, weight can be resolved into two components, perpendicular to inclined and along the inclined. So 20 cos theta and 20 sin theta, correct? Block A 20. So weight I have resolved into two directions, along inclined, perpendicular to the inclined. Now as A and B is having what? There is a friction involved there. So friction force will be acting. Now tell me where the friction force will be acting on block A. See, tendency of motion of block A is upward. Tendency of motion of block A is in the upward direction. So friction force applied by the body B on A will be in the downward direction. This is the friction force. Perpendicular to that there is what? Normal reaction. Let's suppose N1, this is F1. Now all the forces I have mentioned here itself. In the free body diagram, all the forces I have mentioned. Clear? Now apply equations of equilibrium and you can solve. Now next I will draw the free body diagram of block B. Now see, for block B how it will be there. Again, this is what the tension T we will be having. Again, component of the weights along inclined and perpendicular to the inclined. 30 sin theta, 30 cos theta. Okay. Only normal reaction will be coming. Let's suppose N2. Now A and B, please try to understand. A and B is having contact, so the normal reaction at A will be also acting at B. See, same value. Whatever the normal reaction at A is having, opposite, in opposite direction, B, this block B will also have. See, like this. This is the block B we are having. So N1 like this, it will be acting, and friction force will be acting like this. Clear? So for block B, N1 will be like this and F1 will be like this, just opposite to whatever is applied on A. Whatever is applied on A, just opposite to that on B it will be having, because both are in direct contact. So normal reaction on A is like this, on B because of A. See, this is the normal reaction on A because of B, and this is the normal reaction on B because of A. Correct? So this much basics, I hope it is clear to everyone. So similarly, the friction force applied by B on A, and in a similar manner, friction force applied by A on B. So apart from 30 cos theta here, we will have N1 as well, and we will be having friction force as well here, F1, like this. So all the forces I've mentioned, apply equations of equilibrium for this one and this one. I will write equation of forces along inclined. Along inclined plane equals to 0. As equilibrium is maintained, so I will put 0 here. Correct? Along inclined, see, tension T minus 20 sin theta. Okay. Then minus friction force mu into n. Mu value is 0.15. In the question 0.15 is given, theta they are asking. Okay. Mu into n. N value is n1. N1 is 20 cos theta. So this is the friction value, mu into n we have written. So tension 20 sin theta and F1 equals to 0. So this is the equation. Next equation, for this one I can write summation of forces along inclined. Along inclined plane equals to 0 for block B as well. So tension, see, tension T Try to understand. For this one also I am writing like this, tension T minus 30 sine theta, okay, plus this friction force in the direction of T only, F1 value is 0.15 into N1, that is 20 cos theta, like this, equals to 0. From equation 1 and from equation 2 I will compare tension values. From equation 1 and 2 I will compare tension values, and from comparing tension values from equation 1 and 2 I will get the answer of theta. Okay, so just compare it and tell me what answer you are getting. Theta value from equation 1 and 2, anyone? What answer you will get? Just compare equation 1 and 2. See, from equation 1 tension T value will be 20 sine theta plus, because both the values will go to the right side, become positive, 20 sine theta plus 0.5 into 20 cos theta, 0.15 20 cos theta equals to tension T value 30 sine theta minus 30 sine theta minus 0.15 20 cos theta. Okay, so we have just equated tension values from equation 1 and 2, 20 sine theta, 30 sine theta. Okay, so 0.5 into 2, it becomes 3 cos theta. Okay, 20 sine theta goes to that side, becomes 10 sine theta. It is also 3 cos theta. So 3 comes to here, 6 cos theta equals to 10 sine theta. Okay, 10 sine theta, so sine theta divided by cos theta becomes 10 theta, 10 theta equals to 6 divided by 10, which becomes 0.6. So 10 inverse of 0.6 value is what? Yes, absolutely, Rahul Kumar, correct answer, 30.96, correct, superb. Theta answer is 30.96. Clear? So such type of problems you can expect. The only one thing is important here, guys, in such problems, free body diagram. Again I am telling you, in all the engineering mechanics problem, whether it is truss problem, whether it is equilibrium problem, or whether it is friction problems, free body diagram plays a very, very important role here. So equilibrium, friction, truss, all the chapters, free body diagram is very important. Now moving to the next numerical, this one, this is an MSQ, guys. This is a multiple select question. This is a multiple select question, guys. Do it fast, everyone. This is an MSQ problem, and such type of problem you can expect in the GATE examination. See what they have mentioned. Uniform thin rod has a weight 30 Newton, length 2.6. Length is 2.6 meter they have given. Okay, it is placed against the smooth wall. So wall is smooth they have mentioned. And on the rough floor, floor is rough. For that coefficient of friction will be there. That is 0.3. Okay. Distance D is 1 meter. Okay. Which of the following statement is are correct? So how you will identify whether it is MSQ? Is slash are they have given. So maybe 1, maybe 2, maybe 3, or maybe all 4 are correct. So we need to check all. First, it is stationary condition. Second, sliding. Friction force 9 Newton. And last option, friction force at A is 6.25 Newton. I will assume it is under stationary condition. In all the friction problems, first step is you can take like assume equilibrium condition. Okay, stationary condition basically means equilibrium condition you can assume here. While assuming equilibrium equation, apply the equilibrium equations. Equilibrium equations like summation fx, summation fy, summation moment 0. By applying all these equilibrium equations, you will get the friction force. Whatever friction force value you are getting, compare it with the maximum friction force value. If the friction force that you are getting is more than the maximum friction force, in that case it will be what? Moving only, because that much friction force is not possible. Okay, and if it is coming less as compared to maximum friction force value, it is under stationary or it is under equilibrium condition. Got it? Now we'll just solve this question. This point is A, this is B, NB, this is NA, this is FA, this is the weight, 2.6 meter they have mentioned, this is 1 meter, and this one also you can calculate, approximately it will be 2.4 meter. Right, clear? Now first I will assume stationary equilibrium condition, right? Summation of forces, if I take it 0, NB value equals to FA, which is mu. Okay, let me write direct mu value 0.3 into NA. That is the first part we got. Then summation of forces vertical 0, we will get what? NA value equals to W. Okay, let me check. 30 Newton is the weight they have given. Okay, which is having 30 Newton weight. Now third part, summation of forces, summation of moment value about point A0. Let us take summation of moment value about point A0. So what I will be getting? W multiplied by 0.5 distance. Okay, clockwise, NB anti-clockwise. So NB, in place of NB I will write 0.3 into NA. This is the value of NB multiplied by distance 2.4. So from here W is 30 Newton. Okay, 30 into 0.5. This is 0.3 into NA multiplied by 2.4. So NA value you will be you will be getting from here the NA value. Okay, not NA value actually. You will get the friction force value. Okay, you will get the friction force value. Just let me write it again. Okay, simply this is 2.4. So in order to calculate this friction force here, okay, because I have taken what? Equilibrium condition. So summation force Fx0, summation Fy0 and summation moment 0. So friction value, okay, whatever the friction value is there. So we can't, let us take Fa only, because see this point very important here. I will write directly here, I am not writing coefficient of friction, I will directly write here Fa. Directly I am writing Fa value. Reason why I am writing Fa value? You can ask, sir, why you are writing Fa? Because at this moment I don't know whether it is having impending motion or what kind of motion it is having. Impending motion is there or not, because to write friction force as mu into n, this is only possible if impending motion condition is there. It is not confirmed whether it is impending motion or not. I don't know about that. So I cannot use directly this one. So I will directly put Fa value here. I will put directly Fa value. From here Fa value I will be getting. That is friction force value at A. That friction force value I will compare it later on. Do the calculation and tell me your answers. Okay, this is NB, not this is NB. Sorry for the mistake here. This is NB here. So from here NB value you will be getting. Okay, and finally NB value from this equation. Okay, as this is what FA value, friction at A. So NB value, whatever NB value you are having, you will get FA, friction force value at A. Okay, write down fast everyone this thing and tell me the answer of this NB value. Tell me the answer of NB value first. Approximately 6.25, not 62, 6.25 it is. 6.25 it will be there. Just cross check. 6.25 it will be there. You can cross check the values. W weight is what? 30. 30 into 6. 6.25. Yes, now it is correct. Absolutely. NB value is 6.25. So friction force value we got 6.25, but maximum value of friction at point A is mu into NA. Mu value 0.3. NA value is 30, which is 9 Newton. Now compare it. Friction force as per the equilibrium condition, friction force should be 6.25, but maximum friction force is 9. So if my actual friction force value is less than the maximum value of friction force, obviously it will be under equilibrium condition. Obviously it will be under equilibrium condition. It is under stationary condition. It will not be moving. And actual friction force will be 6.25 only. This is your answer. Not this one, because this is more as compared to this one. So this much only friction force will be applied, not this one. So in the initially I have told you this point. You have to compare the value of friction force with which the applied external forces. Correct. Static condition, yes. So option, which options are correct here? This is option A here. Rod is under stationary condition, correct. Force, friction force acting at A, 9 Newton. This is wrong here. This option is wrong. Option D is correct. Option D is correct here, right? So once again, I will tell you this point. Please remember, whenever such type of question comes, where we don't know whether it is impending motion condition, stationary or moving, we don't know anything about the question, we will simply assume body is under stationary condition, or we can assume it is under equilibrium condition. Based on equilibrium condition, this was the friction force acting. I have assumed some friction force is there. Right now, I cannot write mu into n. Previously I have written, that's why I have removed this thing. Mu n I cannot write, because I don't know whether it is impending or not. So directly FA value I have written. I have applied equilibrium equations only. Summation Fx 0, summation Fy 0, summation moment 0. By applying equilibrium equation only, I got the answer of friction at A is 6.25. Because NB equals to FA, 6.25 I got while taking moment about point A. So when I got this answer, then I will check this answer with my maximum value. And only one formula is there to check the maximum value. So when I have compared it, this is more compared to the actual value. So why this maximum value will be acting? Only this actual value will be there. So that's why 6.25 is the correct answer. So that's why people by mistake will mark this answer, because they will always apply friction force formula mu into n. In the starting of the friction topic only I have told you, never write mu into n until and unless they have mentioned impending motion condition. Until unless they have mentioned the impending motion condition, you should not use mu into n as a friction force formula. Clear everyone? I hope this particular problem is clear. So such type of MSQ you can expect in the GATE examination. Now let's move to the next numerical here. Okay. So yes, this is also a very good problem actually, related to overturning. Okay, yes, un is the maximum frictional force value. Now this is the overturning case and most expected question nowadays from last 2-3 years. Mostly they are asking question related to overturning. In civil also they have asked one question, in mechanical also. See, they are asking what, determine the maximum height at which force P parallel to this inclined plane can be applied. This H we need to find out, so that what happens without tipping over. If I apply a force, there is a chances, let's suppose this is A, this is B, there is a chance that this block can tip over at point B, it can turn. Okay, overturning can happen at point B, that is a possibility that we need to avoid. So what should be our maximum value of H for that? Okay, only 1 point is what required here. Okay, 1 point. What is that? The limiting condition. Okay, this is a block. First horizontal case you should understand. If I apply a force P at some height H, so there is a chances that at B it can turn like this. It can turn like this. Okay, not like this, it will turn like this. Okay, there is a chances that it will turn like this. Like this it can turn, correct? But how to avoid? Okay, how to avoid such situation? Okay, under what circumstances it can be avoided, or what is the maximum or the limiting condition in which it will not overturn like this? It cannot overturn like this. What is the limiting condition? Only 1 point you need to know. Okay, now see what is that point. The normal will shift towards the corner. The normal, okay, normal reaction shift towards the corner. Normal reaction will shift towards the corner. Which corner? Where the rotation is happening. Rotation is happening at this point. How I've identified? Obviously, P is acting here. It will try to rotate about this point. So the normal will shift at this point. Now, when normal has shifted to this point, that is our limiting condition. For that moment, you can apply the equilibrium equation. Okay. For that moment, if you apply equilibrium equation, you will easily get the answer here. Correct? No, directly mu n equals to pH, how you will write? No, not at all possible. See, what we have to do? We have to write summation of moment equals to 0. About which point? Any point, because I am talking about equilibrium condition. I am talking about equilibrium condition, right? I can take it any point, but remember, normal is always shifted to that corner where rotation is happening. Done? Okay, so let's suppose I have taken at point B. This is what my W weight is acting. This distance, this base of the block is A. So how I will write moment? P into H. Moment because of P at B is P into H. W moment will be W multiplied by A by 2. Is it clear? Is it clear? Yes or no? Tell me. Is it clear? P into H equals to W into A by 2. I have written. From here you can calculate the value of H. Tell me everyone, is it clear? Yes or no? If it is clear, then only you will be able to solve the numerical like this. This kind of numerical is only possible if you understood this concept. Clear? Superb. Okay, great. Now we can easily solve the problem here. Actually, this is the basic problem. This is the basic problem. Advanced version of that problem is this one. Okay, advanced version is this one. So let us solve this one also. Okay, so P value, first of all, P value for sliding, P value how much the value of P should have for sliding. So summation of forces along inclined equals to 0. So P, okay, friction force will be acting like this. Friction force, normal direction will be like this. No, just wait a minute. P value, okay, P is the force towards in the upward direction, friction force in the downward direction, minus mu into N. Apart from that, weight component of the block will also there, na, W sin 30 degree. This is W cos 30 degree. Correct? So minus W sin 30 degree equals to 0. So from here I will get the answer of P. W sin 30 degree. Clear? So from this equation I will get the value of P. Now this value of P I will utilize. Okay. Now try to understand. As I told you, limiting condition is what? You have to identify at which corner rotation will happen because of this external force at this point. So shift your normal to that point. Shift your normal to that point and take the moment equilibrium. And then take the moment equilibrium, right? Okay. Next what I will do, I will write down the equation of equilibrium. Okay, equation of equilibrium we will be taking, let's suppose moment about point B. Clear? Now, let me just write the equation, because just I will draw the free body diagram for you. This is H, this is W sin 30, W cos 30, this is normal reaction, this is the friction force. Okay, obviously friction force and the normal will not have any moment about B point. This is A, this is B. So moment at B we want to take. So P into H, first of all, P into H, then W sin 30 minus W sin 30 multiplied by the distance. What was the distance? Half of 60, 30. Okay, then W cos 30, okay, W sin theta anti-clockwise, W cos theta again anti-clockwise, minus W cos theta multiplied by half of this distance, that is 40. 40 half is 20, equals to 0. Now P value we have written, P value is this much. Mu, coefficient of friction they have given 0.2, yes, correct, 0.2 into N value. N value will be W cos 30. Okay, plus W sin 30 plus W sin 30. So this is the value of P. Again please cross check. 0.2 into N, 0.2 into N W cos 30 plus W sin 30, W sin 30, okay, fine, into H. Both the values are on the negative, so I will take it on the right side. So W sin 30 multiplied by 30 centimeter plus W cos 30 degree multiplied by 20. So from here you will get the answer of H very easily. W will get cancel out, don't worry about the W. Easily you will get the answer. Now please do the calculation, guys, fast. Do the calculation for the value of h, everyone. Right? Now it become very easy. Do the calculation part. Do the calculation everyone first and tell me your answer. Done. See, now the question become very easy for you. Like, okay, easily you can do the calculation, right? So that part I'm leaving for you. In the comment box, you can mention the answer later. Now, equilibrium we have done, truss part we have done, friction part, expected numerical also we have done. Centroid is very easy part, moment of inertia is also very easy part. I will give you one question for homework, okay? I will give you one question for homework, right? I am giving you some question for the homework, okay? You can try. This question from the friction again. This is as a homework, you can do it. I will provide the solution in the Telegram group. In the starting, I've told you, na, description box also, okay? In the description box of this particular video, you will have a link of the Telegram group. Join the Telegram group. You will get the answer of this particular problem also. This is as a homework for you, okay? And you can also mention the answer in the comment box later. Okay, this is as a homework, but later I will provide the solution in the Telegram group. Okay, don't worry about that. Okay, this one also, yes, this one also, this problem. This is also an MSQ problem from the friction only. For this one also, I will provide the solution in the Telegram group. So please join the Telegram group, right? You will get everything there. But this is as a homework for you guys, okay? And I want everyone to mention the answer in the comment box also. I will reply you. Okay, I will personally reply you in the comment box also. Now, the last one thing, and this part, centroid calculation. Again, I'm telling you easy part, but still sometimes because of some calculation mistakes, or sometimes we will put wrong values in the formulas, we'll get wrong answer also. Very easy part, okay? Just one thing I want to tell you, okay? I will give you the hint regarding this one. Centroid formula is A1 x1 plus A2 x2, A1 plus A2. Whenever in the section some hole is cut, so in the circular plate, this square section has been cut. From the circular plate, this square section has been cut. So for this area, we need to find out the centroid. Clear? Rahul, tome we will have in December 2nd week. Okay, you can see the playlist. Okay, you will see all the playlist there in the our YouTube channel. All the details, all the upcoming sessions are updated there itself. Date is 16th December. Sorry, I'm sorry for that. 16th December. So you can check the, please subscribe the IMS Gate Academy YouTube channel. You will get a notification also, and in the Telegram group I will inform also. In the Telegram group also I will inform, okay, but the date is 16th December. Okay, now area A1, let's suppose I am taking for a circular plate. Area 2 I am taking for the square. But when I am writing a square area, I will use negative sign. I will use negative sign there because it has been removed. So area I have to take it negative. Clear? So that information you need to know. Then remaining part is very easy. This is also homework for you guys. This is also homework. Okay, answers you will be getting in the PDF. Okay, that will be uploaded in the Telegram group. Now next, last part of the session is undamped vibration. Undamped vibrations, basically we have to discuss for single degree of freedom system. Okay, only 1 or 2 formulas are important here, 1 and 2 formulas. So try to understand. First of all, free vibration. I will tell you some of the points here. Natural vibration means no external force will be involved. Undamped vibration means no damping. Single degree of freedom basically means degree of freedom is 1. Degree of freedom for the system is 1. So vibration, okay, you want vibration separate, okay. See, theory of machine we will do in 2 sessions, so next session we can take for vibration. And I am telling you, for the vibration, after attending vibration gate booster session, you will never feel any doubt in the vibration, because I will cover in vibration in such a way that concepts as well as all the quality problems will be done in the session itself. Concepts also we will be discussing. How to approach a question of finding natural frequency. Those type of questions I will do in the session itself. Basically I will tell you the approach so that you can solve the question on your own. Right? So basic meaning should be clear. Now what point you need to remember? Specifically for a spring mass case, okay, spring mass system like this. You can have like this also. Or even you can have like this. In all the cases guys, omega n formula is under root k by m, and the frequency in terms of hertz will be omega n by 2 pi. Clear? Yes, Rahul, torque method. Don't worry about that. We will solve problem with the help of torque method only. Don't worry about that. Okay. And actually the torque method is one of the easiest method. Okay. Don't worry about that. Omega n frequency. Then time period of oscillation is 1 by Fn. These 3 relations are very, very important. All 3. Time period of oscillation is the time required to complete one period of oscillation, one cycle of oscillation. How much time is required? 1 by Fn. Fn is number of cycles per second. This hertz basically means cycles, number of cycles per second. Clear? So this is very, very important parts. Clear? So if you remember this formula, all of the previous year vibration question you can solve. I am talking about for civil engineering students. For civil engineering students I am talking about. Okay, for them the questions will be very easy. Just solve previous year questions. Okay, you will understand what kind of questions they are asking from engineering mechanics. civil part I'm talking, specifically for civil. This is not for mechanical. Mechanical we have entire vibration chapter different. Okay, different concepts will be there. The syllabus part of mechanical vibration is very different as compared to vibration part of engineering mechanics that civil students are having. So for civil engineering students, engineering mechanics, in engineering mechanics, vibration part is very less. With the help of these three formulas only, you can solve any variety of problem in your engineering mechanics subject for civil engineering students I'm talking about. Okay, so thank you so much guys. Okay, you have solved so many questions here. Okay, and I hope you get some concepts as well here. You will get the PDF of this session guys. You will get the PDF of this session in the Telegram group. So again, just let me remind you regarding the Telegram group that we are having. Okay, in this Telegram group, okay, you can join the Telegram group. You will get the PDF and as well as the PDF of this session. In the Telegram group itself, you will get all the PDF of Gate Booster sessions as well as all the important notification, okay, job notifications and webinar details that we are conducting for the GATE aspirants. You will be getting all the information as well as the quizzes you will be getting in the Telegram group. Okay, and in the last this live program that we are having, you can join this live program, GATE live classes. You can join 8 hours, 800 hours plus courses there. You will get exercise book, theory books, everything you will be getting, and most important feature is this 12 one-to-one mentorship sessions. With this mentorship session, you can directly connect with your faculty and you can discuss whatever challenge you are facing in your GATE preparation part. Okay, so this is more than 800 hours of session, right? All the classes will be live and you can enjoy your GATE preparation journey with IMS GATE Academy. Okay guys, thank you so much. We'll meet you tomorrow again, same timing 6 p.m. for the dynamics part of engineering mechanics. This is the part 1. Next part 2 is dynamics, which is only for mechanical people. Okay, so thank you so much guys. We'll meet you tomorrow at 6 p.m. for the second part of engineering mechanics. Bye bye.